Hello, Miss Kaylee. This is your first video link for the class from Monday, March 6th. So you will watch 3, and this is the first of 3. So welcome to class on March 6th. Our content objectives for class on March 6th are to review levels 1, 2, and 3 for solving addition, subtraction, and multiplication problems. Experience an instructional routine for implementing a problem-based lesson. You have your first lesson plan due next week, and I'm going to walk you through an instructional routine that you could use as a framework for your first lesson plan that you develop. And then finally, construct critical understanding regarding the development of fact strategies. We started class by reviewing level 1, 2, and 3 strategies from the week before. If you remember, we worked with 8 plus 6 the week before, and we talked about a level 1 strategy where a kid might count out 8 cubes, count out 6 cubes, and then count all the cubes, every one of them, to reach 14. Versus a level 2, a kid may count out 8 cubes, may count out 6 cubes, but then would say 8, 9, 10, 11, 12, 13, 14. So that's counting on, that's a level 2. And a level 3 is the use of another fact strategy, so it involves decomposing one of the quantities. So for instance, this one counts out or draws 8 circles and 6 circles, but then circles 8 and 2 more to make a 10, and then thinks 10 and 4 to get 14. So that was just a quick review of those levels of strategies. Multiplication, they might draw 6 groups with 4 stars in each group and count every single star. That would be a level 1. Skip counting by 4s or 6s to solve 6 times 4, that would be a level 2. And then finally, the use of a more efficient strategy, so decomposing one of those factors. So decomposing the 4 into 2 and 2, so thinking 6 times 2, 12, and doing 6 times 2 again, so 12 and 12 is 24. That would be a level 3. All right, we are going to go into this instructional routine for your problem-based lesson, or your lesson that needs to come from the operations and algebraic thinking domain of your standards. It can be any grade level. Your main focus needs to be an operations and algebraic thinking standard. So we're going to go through a quick routine that may be helpful to you as you develop your lesson. What we need to think about, first of all, is helping all kids access high levels of mathematics. And we can build confidence in our kids by doing 4 of the following things. We can help them make sense of and persevere in challenging mathematics. We can facilitate meaningful math discourse. So we can have conversations about problems we're solving in math, and we can get kids to talk about them and communicate and have that meaningful conversation and discussion about each other's ideas. We can support productive struggle in mathematics. We don't want things to be too easy. We want kids to persevere and be able to attack and stick with a problem and work through a problem without getting too frustrated or getting to that shutdown mode. If they get to a frustration level that causes a shutdown or other behavior problems, that's an unproductive struggle. We want a productive struggle in our math classrooms. And then, of course, we can elicit and use evidence of student thinking. So to talk about the math that's going on, to talk about strategies, you want to use student work to talk about that, to spur those conversations on. So you're going to see an instructional routine that helps you do just that. So today, our class on Monday, actually, they were students, and so they got to experience this, but throughout the lesson I also talked to them teacher to teacher about this lesson instructional routine. So we're going to start with a photograph for a problem-based lesson. So a problem we're going to solve today in math, we're going to start with a photograph, and this is a screenshot of my phone screen. And so the first question I ask is, what do you notice? You look at this picture, what's something you see? What are 3 things you see? What are 2 things you see? Give the kids some think time. So I gave our class like 15 seconds just to think on their own, things they see, looking at this photograph. And then I gave them a turn and talk, okay? So I'm not asking anyone to share in the whole group yet, but I want them to just share with one other person. A lot of kids feel safer sharing with just one other classmate than being asked to share in front of the whole class right away. So we did a turn and talk. And they listed all the things they saw. Our class listed 10% battery. 9:34 is the time. AT&T is my carrier. I only have 2 bars. I'm on Wi-Fi. My alarm is set. I have Do Not Disturb on. My phone has Bluetooth. It's plugged in and being charged. The picture is taken outside. There's flowers in the picture. There's a brick wall in the picture. All of those things were listed. So then the next step of this instructional routine is, let's look at this same photograph, but this time the question is, what do you wonder? What are your wonderings thinking about this photograph and this phone screen? Again, 15 to 20 seconds of think time. Turn and talk. Tell your partner, what are some things you're wondering? Our class on Monday came up with, why do you have the Do Not Disturb on? Who do you want to not disturb you? What time is your alarm set for? Where are you on Wi-Fi? Why is your phone all the way down to just a 10% charge? How long has it been plugged in? Is it AM or PM? Are those your children? Is that outside your house? All kinds of wonderings. Again, everything's accepted, everything's acknowledged. I recorded their wonderings and the things they saw in the picture to begin with. I recorded those on 2 pieces of chart paper in front of the class, which I would do with students in an elementary classroom as well. So here's the next step that we want to get to, which is our actual task and our problem that we have to solve. What time will it be when the phone is fully charged? So that is the math task that I'm getting at. But right now, because I've done what do you see, what do you wonder, where everything's accepted, there's no right or wrong, I've got the whole class engaged in my lesson. And now I pose my productive struggle problem. What time will it be when the phone is fully charged? Obviously, this is a question where there is not one right answer. It is one of those open-ended, deep thinking questions. Before I ask them to just start digging in to solve this, I ask for 3 estimates or hypotheses. And a hypothesis that is too high. So no way it's going to take until this time to get to 100% charged. A hypothesis that's too low. No way it's going to be at 100% charged at this time. And a hypothesis they think is just about right. Okay? So they come up with those 3 estimates. A way too high, a way too low, and one that they think is about right. And we record some of those, and I even asked some of the kids, okay, why do you think this is just right? How can you justify that? Why are you thinking that's probably going to be about the time? And they explained some of them had experience with their own smartphones and how long they take to charge, things like that. So you can ask for reasoning even at this level. And then I asked the kids, do you want some more data? Do you want some more information? So here's a good time to pause, get yourself a Post-it and something to write with, because you might want to write this down. 9:34, 10% charge. Here's some more data for you. 9:44, 15% charge. 9:55, 20% charge. And finally, 10:02, 25% charge. So now they have some more data to work with. At this point, I sent them with a partner and a piece of chart paper to go ahead, given the information they have, to go ahead and work out a solution to this problem, recording their thinking on chart paper. So I would like you to pause right now, and do the same thing. Okay, as our partnerships were working, I was actively monitoring. So I was walking around, I was observing, I was listening in. I watched partnerships work, I watched them record. Sometimes I would stop and ask them to tell me a little about about their strategy, about what they were thinking, how they got their number, how they were determining their time frames and their intervals of charge going up, things like that. That's when our math practices are really highlighted, when students are working and the teacher is actively monitoring, observing, asking questions, digging deep into student thinking. Again, not giving away any information, not telling kids what strategy to use, but just asking some very thought-provoking questions. So I'm not sure what strategy you chose to use or how you decided to get to that 100% charge in your time, but here are some things our class came up with. Let's see if I could get to the next slide. Okay, so I believe this was William and Veronica's. So they literally started at 10:02. At 25%, they went up by 5% increments, and they went up by 10-minute increments. And they went up by those individual increments all the way until they reached 100%, and it was 12:32. So that was their strategy. Think about that strategy compared to your own, but also think about this strategy compared to Yvette and Anika's strategy. They discovered that in the data I gave them, there was 28 minutes, and in that 28 minutes, it went from a 10% charge to a 25% charge, so that's a 15% increase in charge in 28 minutes. They then decided, well, if you went up another 15%, that would get you to a 40% charge. And if we go up another 15%, they decided to go up the same amount of minutes, so another 28 minutes. So you can see on their first row of information there, they're at a 40% charge at 10:30. And they went up in 15% increments until they got to their 100%, or as close as they could, which was 11:59. Think about how this compares to this strategy. And of course, this is a great time to talk about, well, how are they similar? How are they different? And which one might have been more efficient? Okay, so when I selected work to share with the class, I purposely, intentionally, as a teacher, I selected this piece of work to share first. I selected Yvette and Anika's work to share next because it built on William and Veronica's work, but it was slightly more efficient. And then the last piece of work we shared was, this was from, I believe, Adam and Aspen. And they did some more precision type computation to get their answers. And so if you look at the top, they again thought about the 28 minutes, and that was in 3 different increments of time. So they had an average of 9.3 minutes for a 5% increase, which then Adam did a beautiful job of communicating this to the class very precisely, about how they went about using this information and the math they did to discover at the bottom, as you see, 12:17, 100% charge. So that was the instructional routine we used. I also gave a sample lesson with this instructional routine. The sample lesson I gave, it's a model lesson, it says model lesson plan. I probably shouldn't have called it a model lesson plan. I really just took the Friends format and I put in this lesson that I did with the class as a sample. I emphasize that this is not an exemplar lesson. If this lesson plan were to be turned in, it would not get full credit and receive the highest scores on the rubric. But I wanted you to see how this instructional routine fits in with an opening, work time body, and closing of the Friends format of a lesson plan. You could use this routine as you develop your lesson for operations and algebraic thinking. This article is also in your set of materials. We did not read it in class. It's an article that supports what you've been reading about in your text, and it supports using problem-based lessons, which our text talks about a lot, in order to increase math fluency and that procedural fluency, but starting with a problem in context and having a problem-solving opportunity, and then for students to share their thinking and their strategies and how they build on each other. And now you are ready for your second video link. Email me if you have questions, especially about the lesson planning. I know that can get tricky doing the first one.